video, I would like to tell about the relational learning improves prediction of mortality in COVID-19 in the intensive care unit. Then we are going to see about the overview of our process. In our process, the main objective is to predict the mortality in COVID-19. Then we have to implement the machine learning as well as deep learning algorithm. After that, we have to enhance the overall performance for both classification algorithms. Okay, traditional machine learning models have had limited success in predicting COVID-19 outcomes using EHR data, partially due to not effectively capturing the interconnectivity patterns between various data modalities. In our model, we use an LSTM for processing time varying patient data and apply our proposed relational learning strategy in the final output layer along with other static features. Here we are taking the input dataset as COVID-19 mortality patient details. We will collected the dataset from dataset repository. Actually, the dataset also mentioned in our research paper, that we have to take the dataset as input. After that, we have to implement the machine learning and deep learning algorithms for predicting mortality in COVID-19. Finally, the experimental result shows that the accuracy, that is overall prediction, then comparison graphs for both algorithms. Now we are going to see about the flow of our process. First, we have to take the input data set as COVID-19 mortality data set. After that, we have to take the input data from our data set. Then we have to implement the pre-processing step. In this step, we have to handle missing values, label encoding, and drop unwanted columns. Actually, pre-processing means to remove an unwanted noise or unnecessary data from our input. Handle missing values means we have to check any missing values is present in our input data. Is there any missing values is present, we have to replace the missing values by zeros or non-values. After that, we have to implement label encoding. This is to encode the data as labels. After that, we have to remove unwanted columns, that is which columns we will not use in our process. That's purpose only we have to remove or drop the unwanted columns. Then we have to implement the data splitting. In this step, we have to split the data into test and train. In the test means a smaller portion of the data, train means the most of the data are present. We have to split the data is based on the ratio. After that only we have to implement the classification algorithm. In this step, we have to implement machine learning algorithm and deep learning algorithm. In machine learning, we have to use random forest. In deep learning, we have to use LSTM. After that, the performance analysis. Finally, the result will shows that accuracy for both algorithm, that is random forest and LSTM, and also comparison graph for both the algorithms. So this is the flow of our process. Next, we are going to see about the demo part, that is our output. Okay, we are running our process in a Spider IDE from Anaconda Navigator. Okay, this is the sample data from our data set. Just I have displayed some sample data. Okay, so the data set contain the code and disease name, disease, and so on. After that, we have to implement the second module, pre-processing step. In this step we have to handle missing values and label encoding if needed, and also we have to drop unwanted columns. We can. Okay, first we have to handling missing values. Here first I will check is there any missing values in our dataset. Yeah, here occurred on missing values in the attribute name phd code. So we have to remove that missing values, so that after handling missing values there is a no missing values, right? Here 0 means there is a no missing values in corresponding attribute. I have modified that. After that we have to label encoding performs. It is encoding the data to label. Okay, here label encoding, before label encoding the data is like, after label encoding it will convert it to the like this. Then we have to implement the machine learning algorithm and deep learning algorithm. In machine learning algorithm we have to implement the random forest, and the random forest occurred 99.58 accuracy. The accuracy means the overall prediction. After that we have to implement the long short term memory, that is a deep learning algorithms. Her result is so after running our result the accuracy is 85%. Thus we have to visualize the comparison for two algorithm RFF and LSTM. In our process finally we conclude that machine learning algorithm gives the best result when compared with deep learning algorithm. Okay, so it is the variable explorer. The variable explorer means the variable in our process which variables we are used, that variables will be stored in that part. So this is the output part. Thank you.